Hi guys, I know I'm not here today, but I'm here to virtually teach you. Today we're going to talk about energy flow, and so I am going to be in one of these corners hanging out so you can see my face, because why not? And we're going to take some notes today. So what you're going to need to do is go into your notebooks, and we are going to use page 53 in your notebook. So open up your notebook right now. Take a minute to set up your page 53 to be Cornell notes. I'm just gonna wait. You can pause the video if you need more time. Okay. All right, so here we go. We're going to talk about energy flow, and this is a topic that is going to be on your final exam. And yes, I know I'm not here to teach it to you, but this is the next best thing, right? So we're going to talk about energy, and we've been talking about how carbon is recycled, but energy is also cycled through an ecosystem. And in nature, there are two kinds of things. Everything that's alive is one of these two things. So you should definitely write down the bolded terms that I have here. You will need to know them. The first is producers, and producers are organisms that get their energy from the environment to make food. So these are things that can actually do photosynthesis, or a process similar to photosynthesis called chemosynthesis, in which organisms use something other than sunlight to make their food. But these are organisms that can make their food. They don't eat food. So every plant is a producer. And then if you don't make your own food, you have to eat your food to get your energy, and you are considered a consumer. A consumer is an organism that eats other organisms. So every human on Earth is a consumer. So I want you to take a moment right now and think of some examples of producers and consumers. And I'm going to have you pause the video, turn to your partner, and talk about that for 60 seconds. So pause the video, take a moment, come up with at least an example of a producer and an example of a consumer. Go. Hi, you're back. Yay. Hopefully you came up with an example of a producer and consumer. It's not too hard to come up with one, but here are some that I've come up with. So, right here, this is a cow. A cow is this is like Dora the Explorer, like you can say it out loud and I can't hear you, but say it. What is a cow? Great. Hopefully you said consumer, because cows eat to get their energy. And usually they eat grass. So here's grass. Grass is a great producer. Palm trees. Palm trees are a, if you said producer, you're right. Here's a sloth, my personal favorite animal. It is, of course, a consumer. Kelp is a producer that we have here in California. And grasshoppers are, of course, consumers. It's pretty easy, right? Everything is a producer or a consumer. You eat or you make your own food. All right, we're going to take it a step further. So there's actually 4 different kinds of consumers we're going to talk about today. If you consume to get your energy, then you might be an herbivore, meaning you eat only plants. You might be a carnivore, meaning you only eat other animals or other consumers. You might be an omnivore if you eat both. Omnomivore. Or you might be a detritivore or decomposers. These are organisms that are incredibly important to our ecosystem because they eat the dead stuff. And can you imagine if we didn't have detritivores or decomposers? I mean, every dead thing ever would still be here. Ugh. All right, so at the beginning of class, hopefully you received a sheet of paper that had several different organisms on it. So what I want you to do is you're going to cut apart those organisms and you're going to sort them into piles. So I want you to pick out all of the producers and all the consumers. And once you find your consumers, I want you to determine whether it's an herbivore, a carnivore, an omnivore, or a detritivore/decomposer. So using your notes, I want you to figure those things out. This is the point in the video where we're going to pause and you are going to work on this. If you need help from classmates or your group mates, totally get help. This should take you about 5 minutes total to do. So go ahead and sort those things out, pause the video, and I'll be back when you're done. All right. Hi, welcome back. Hopefully you found that easy. All you need to do is read what that animal consumes, if it's a consumer, to determine whether or not it's an herbivore, carnivore, omnivore, detritivore, and if it's a plant, it's a producer. Pretty simple stuff. All right, now we're going to talk about food webs. So a food web is something that shows how energy moves through an ecosystem. And I'm sure you've seen food webs before. They're nothing new. You probably have seen them as early as elementary school. But here's what you might not have recognized. The arrows in the food web show which direction the energy is going, not who is eating who. Because here we have a squirrel. And the squirrel is eaten by this coyote. But the arrow is going from the squirrel to the coyote. What that means is that the energy that is contained within the squirrel is being given to the coyote. Not that the squirrel is eating coyotes, because that is terrifying and that is not happening. So every time we draw arrows on a food web, we're actually going to show which way the energy transfers. And of course, where is the ultimate source of all of this energy? Like, tell your partner, because I can't hear you. If you said the sun, you are correct. So the ultimate source of all of this energy is the sun. And the sun is being used to power photosynthesis, which is happening in these producers down here. And that energy is being transferred to consumers and then, of course, higher consumers as the first consumers are eaten. So now what you're going to do is you are going to make your own food web. So using those pictures that you sorted out earlier, those are your personal pictures. You are going to look in your notebook on your page 52, and you can use up the whole page. You are going to glue the pictures down to your notebook or tape or glue, whatever works. And you're going to draw arrows between the organisms to show how energy is flowing through the ecosystem. Remember, the arrows show which direction energy is flowing, not who is eating what, because squirrels are not eating coyotes out there. I hope. Please. So, make sure you draw your arrows the right way. And this activity should probably take you about 10 minutes. So at this point, pause the video and get started with that. If you need help, ask your partner, make sure you guys are all doing your arrows in the right direction, and have fun. All right, hi, welcome back. Hopefully you successfully made a food web. It's not too hard to make. We're just making sure the arrows are going the right direction. So remember, arrows go from the organism that gives the energy to the organism that consumes it. So next we're going to talk about something called an energy pyramid, and this might be a new thing for a lot of you. Food webs show us where the energy goes, but it doesn't tell us how much transfers each time. So, excuse me, I just burped. Sorry. Back to the lesson. Energy pyramids show us the amount of energy that is transferred each time one organism consumes another. And each of the levels of the pyramid, if you can imagine a pyramid, each level of the pyramid is called a trophic level. So on an energy pyramid, we can also call it a trophic pyramid. Sometimes people call it that because trophic levels. So I'm going to show you an energy pyramid. Here's one example. So the bottom of a pyramid is obviously the biggest, and that's what we have the most of. I mean, look around in your world. Are there more animals or more plants? Hopefully you feel like there's more plants, because there are. In the world as a whole, there are more trees and grass and shrubs than there are of animals. This makes sense. So if we look at the pyramid, the bottom is the producers. The second level of the pyramid is where the herbivores sit. These are the organisms that are going to eat only producers. The pyramid usually has maybe 3 or 4 levels. Occasionally you'll see a pyramid with like a 5th level. But as we go up the pyramid, just like a normal pyramid shape, it gets smaller and smaller towards the top. So if you think about nature for a minute, and you think about, let's imagine the African savanna. There are a lot more gazelles and zebras and, antelope than there are lions. Now, the reason for this is something called the law of conservation of energy. So the energy pyramid gets smaller towards the top. Not all the energy is actually transferred towards each level. So some of the energy on each successive level is lost. Every time one organism eats another organism, some of that energy is lost. It's not perfect. It's not a perfect transfer. So in order to support the owl up here, we need more snakes and moles here, and we need even more grasshoppers and bunnies here, and we need even more producers down here. So, the law of conservation of energy is a law, similar to the law of conservation of mass. The law of conservation of energy says that energy is not created or destroyed. So, the energy that a plant produces, it comes from the sun, and it's being converted into another form of energy. And when I eat that plant, I get some of the energy, but not all of it. But it's not destroyed, so where is it going? That's the big question. Okay, before we talk about anything else, this is so important. Okay, really quickly, what is the difference between a theory and a law? For all the brownie points, for 1,000 life points, I don't know, whatever you want. All my love, you have it. What's the difference between a theory and law? Pause the video, answer it to your partner. If they don't get it right, slap them in the face. Just kidding, don't slap anyone in the face. If they get it right, give them a high five though, because they are awesome. What is the difference between a theory and a law? Okay, I'm gonna give you a few seconds to talk about it. All right, if you said that a theory is why something in nature occurs and a law explains what occurs, you are awesome. So that is the real difference. Theories and laws are equal. Remember, they're both important to science, and a law is not like a grown-up theory, and a theory is not less than a law somehow. They're both super important to us. It just gives us different information. So when we're talking about the law of conservation of energy, it states that energy is not created or destroyed, but it doesn't tell us why. It's just a law. That's okay. But this law is very important to us right now. So back to this law. I mentioned that the energy is not created or destroyed, but somehow it's not all being transferred. And energy is measured in kilocalories, or if you read a food package, it's just calories with a capital C. So down here on trophic level number 1, I have grass. Now let's imagine for a minute I have 10,000 kilocalories of grass. Like if I ate all that, that's 10,000 calories. Now, the grasshopper that eats the grass, even if he eats all that grass, he's only going to have 1,000 kilocalories of usable energy. 9,000 calories are somehow lost to him. They're not destroyed because we know that energy is not created or destroyed. The frog that eats the grasshopper will only have 100 kilocalories. The snake that eats the frog will only get 10. And finally, the hawk that eats the snake will only get 1. So you should notice a pattern right now. And that pattern is each time we move up, only 10% of the energy is transferred. That is what we call the rule of 10%. Approximately 10% of energy transfers to the next trophic level. This means that for the hawk to get 1 calorie of energy, there has to be 10,000 calories of grass for this to work. Now, where does the rest of that go? A lot of it is actually lost as heat. So right now, as you are sitting in my extremely cold classroom, well, I don't know if it's cold today, but I'm assuming it is cold. As you're sitting in the cold classroom, a lot of your energy is being lost to just heat giving off on your body. The process of energy transfer is not perfect. So a lot of it is being, quote, lost, and it's being turned into a form that's not usable to us. Now remember, we need glucose to be turned into ATP as our usable form of energy, but it's not a perfect process. It'd be like if you were to put $1 in a change machine, and you're expecting to get out 4 quarters, and instead you get a dime back. It's not perfect. So what's important to realize is that the reason why we have such a small amount of top predators in ecosystems, think about your top predators, your lions, your sharks, your tigers, bears, things that are at the top of their trophic pyramid. There aren't as many of them as there are the herbivores and the producers, because they lose so much energy by the time it gets to the top of the trophic pyramid. All right, another important note about energy pyramids is that it is possible for an organism to be on more than one trophic level. For example, if you eat a burger that has a bun, lettuce, and tomato, how many trophic levels are you inhabiting? If we go back to this picture, way back, this picture. If we go back to this picture, you realize that you would be inhabiting the herbivore portion of the pyramid, so the first level after producers. You would be there if you eat a tomato. But because you're also eating a burger, you are also on the primary carnivore level or the secondary consumer level, because you are eating a cow that ate grass. And if you put bacon on that burger, and we assume that the pig ate meat as well, then you might even be on the secondary carnivore eating a pig who ate something else, who then ate corn or grass or something like that. So you can actually inhabit many different trophic levels at the same time. Now, not just humans, but other animals do it too. Bears inhabit many different trophic levels. For example, bears enjoy eating berries. Now, berries are plants, of course, so they're going to be on the first consumer level, right above the plants. And they also like to eat fish. Now, trout might have eaten other smaller fish, which ate plants. So now that bear is on even a 3rd level, or maybe a 4th level, depending on the fish it ate. So it's not always clear cut where these animals belong on the trophic pyramid. All right, so that is all we're going to cover about trophic pyramids, energy pyramids, the flow of energy in ecosystems today. We are going to do a Kahoot review, and by we, I mean you're going to do it. So in order to get ready for that, go ahead and take out your phone. In a minute here, I will post the link to get to that Kahoot review. And of course, if you're viewing this at home or you're viewing this from somewhere else, you can still log into the Kahoot review and view it. All of the content that we went over today is going to be on your final exam, so make sure that you took good notes. At this time, what I'd like for you to do is get ready for the Kahoot, and also go ahead and write your summary to your Cornell notes, because we are done taking Cornell notes today. So hopefully you enjoyed me virtually teaching you from, my desk here in school, but I'm not here. All right, good luck. Let me know if you have any questions, and have fun. Bye.